TDK has been just a great partner for us. And let's see, I've brought a few slides to kind of share about what we do for anybody who needs that context in this room. You can see there the image of Digit. This is our robot. I call it a human-centric multi-purpose robot. It looks a little bit humanoid, okay? But our goal and our intention is not to make a robot that looks like a person. It just ends up that way when you make a robot that can do useful things, can go where people go, and can work in human workflows. When I talk about human-centric, what I mean is that it is not necessarily like a person, like I mentioned, but it does look like a person. It's for people, okay? But that means it's easy to deploy. So when you have a workflow, like they call these islands of automation in warehouses and logistics, where maybe there's the universal item sortation device, which is putting individual pieces into the bins, and then and that's a whole system of automation. And then there's like the system of conveyor belts, and that's a whole system of automation. And right now it's very manual. A lot of people are basically the glue between those islands of automation, and these are very process automated tasks that people are doing that are very, very hard to hire for. And there's well over 1 million just unfilled roles for these kinds of tasks. I don't even call them jobs, they're really tasks in a lot of cases. And so having Digit be able to just walk into that space, no infrastructure required, be able to do that task that is designed around a human form factor but is very process automated is kind of our perfect beachhead market, the first thing that we're doing as we get into more and more multi-purpose. Safety is another big issue, right? These robots have to follow the guidelines of the AMRs or the cobots or other things, other types of robots that have had enough time to actually create regulations for them. But this really doesn't apply. A lot of those, just an example is, if you hit the E-stop to shut the robot down and cut power, an AMR just stops, Digit collapses on the ground like a person going unconscious immediately, and that's more dangerous than an active safe shutdown state. But that's not envisioned in any of the regulations. So we do need to treat these robots initially like like a cobot or something, and so the robot can work on its own without people right next to it to start with. If a person walks in, the robot will sit down to a low power state before the person can get to it. But then over time, Digit needs to be able to detect people around it reliably so that Digit can respect people's personal space. Digit needs to be able to give natural cues about what it's about to do, just like people do. Your eyes move, your body language a little bit to say what you're about to do, so that people know how to respect Digit's personal space. They don't just run into it in the hallway. And then third, of course, the forces that the robot applies. It has to know exactly how much it's applying and where, so that the physical interaction with the person is also going to be safe. And that's a high bar. It requires a reliable intelligence to do something like that, because the robot must be physically capable of applying forces large enough to pick up a 16 kilogram tote and stand and walk. Those forces are enough to injure a person if applied in the wrong way. But it's inevitable. These robots are going to be working with people and near people and around people. And so figuring out that whole safety and regulatory is a huge part of our engineering effort beyond just demonstrating that it can do the task. And then finally, we're not just doing demos and videos. Like, we're made for work. We are really focused on having robots that do useful things in the world. So that's what I mean when I say human-centric. And when you build a machine that is so human-centric, all of the tasks in these environments are designed around people. That's what enables multi-purpose. And that's the primary value of this kind of robot. So if you pick any one task, there's almost certainly a very specialized piece of automation that would be more efficient, cheaper, and perhaps higher performance even than what Digit can do for that particular case. That's always going to be true. But as a large warehouse and logistics environment company, is it better to have 100 different individual robots that have to take up the floor space and the SKU and everything else to do that one task? They really have to be set up to be 24 hours a day to do that thing. Or one robot deployed across that can do 100 different tasks, and throughout the day, throughout the season, can be reallocated to different use cases and different tasks. So the versatility, the multi-purpose aspect of it, is one of the primary pieces of the value of our robot. So I think that's our overview. And then TDK has been such a great partner. We're talking about kind of a distributed set of InventSense IMUs throughout all of the machine to, as we start to incorporate more and more of these kind of learning approaches that can make sense of such rich data like that. And then, of course, partnering with other investors as we continue to grow the company has been just really valuable here. Thank you.
Thank you so much, TDK Ventures, to have this opportunity. Amazing to see other portfolios. I'm Mohamed Ousmahmedi, CEO and founder of PH7 Technologies, a company with a vision of enabling the global transition to renewable energy. We do this through designing closed-loop metal extraction systems, applying biodegradable and green solvents with organic, inorganic, and electrochemistry. And these closed-loop metal extraction systems can increase the recovery and supply of critical metals up to 50%. The materials that cannot be recycled, recovered, processed, smelted can be processed through our closed-loop process. We have up to 90% energy reduction. We extract these metals in room temperature up to maximum 80 degrees centigrade, comparing to 2,000 degrees centigrade of furnaces from smelters. And we have down to zero carbon emission. We reuse all of our chemistry. We do not generate any wastewater, any effluent, or any off-gassing, and all the extraction is happening in the closed-loop system without generating any waste. We are targeting 3 different markets. The first one we are commercializing right now is the platinum group metals, platinum, palladium, iridium, the critical metals for hydrogen technology that we extract these from a spent catalyst, hydrogen membranes, and electrolyzer, deploy it again into the hydrogen technology. The second one is a copper mining that we are finalizing the development of that phase. Imagine a copper mine with zero environmental footprint, extracting the copper from really hard, low-grade materials of copper sulfide ores, while generating hydrogen as a byproduct that can be used as a fuel for haul trucks. That's what we are doing at copper platform that we have. And the third one is electronic waste recycling, extracting copper, nickel, tin, gold, silver, and PGMs from end-of-life printed circuit boards and electronic waste. Synergies that we have with TDK, there are few synergy, Brad, and investment. We had them as a lead investor for our Series A that we closed a few months ago, led by Tina. And rather than that, we can supply critical metals for the supply chain of TDK equipment and manufacturing, recycling end-of-life materials from TDK's wide variety of the materials that they have, enabling circular economy for TDK, and applying TDK products into our process, specifically power supplies and energy storage that we are using for our electrochemical challenges. Looking for partners in mining industry. So if you can introduce any partners in the mining industry, that would be great. Equipment supply chain. Right now we are actually in this, it's a really crisis. We are building our commercial plant, and still it's really challenging. It's better, but not like before. And hiring talents. So we are growing 30 people right now. We want to be an international company, so growing more talents, and it's really challenging right now, so any help would be appreciated. Thank you.
Hello, everyone. So throughout the summit, we have heard so much to talk about electronics, right? Everybody has developed some type of technology, really cool startups as well. Well, I'm here to talk about how do we protect those electronics from the environment and how we're gonna keep them running. So my name is Alexis. I am Director of Strategic Accounts for Agnano. We are located in Boston, Massachusetts. For anyone that had I know that we had a lot of synergies throughout with the Boston teams. And just really quickly, what is Agnano? Well, we provide nano coatings for the protection of electronics, so printed circuit boards level, and we also provide technologies for protection of glass. Glass, we're talking about anti-smudge, anti-fingerprint, hopefully in the future, anti-fog, and anti-scratch. Those are the 2 divisions that we have currently, and we're developing other technologies and nano coating technologies for the protection of other types of environments. Now, what we are going to be talking about today specifically is environmental protection for printed circuit boards. So, what can we provide for you, right? What is this nano coating technology that you're talking about? Well, the synergies that we have with TDK, which is something that is currently under development in R&D, we are an elastovistoplastic hydrophobic coating. What that really long word means is that we are able to provide a coating that will expand and contract with the differences in environments, so cold environments, hot environments, without creating any stress on the PCBA elements. Additional to that, we don't require any ovens. So traditional conformal coatings, most of them provide any type of curing or thermal, either UV or thermal curing, in order to be able to set the coating. We don't have that anymore. We are 100% also fluorine-free, halogen-free. We don't have any PFAS in our coatings. I know that Joe was talking about the environmental aspect of sustainability. We have a lot of the forever chemicals being completely banned in the European Union and in China. So we don't have any of those harsh chemicals in our coatings. Additional to that, we are able to provide protection of the entirety of the PCBA. So that means no more keep outs. We're able to coat connectors because of those viscoelastic properties that we have today. And we are also able to dry at ambient temperatures between 10 to 30 seconds without the need of any ovens. We provide protection from the environment, which is condensation, rain, any type of sulfur environments, and we're also providing protection in high temperature environments. Not only that, but we apply a lot thinner than any other conformal coating out there. We apply between 10 to 30 microns thick. The thickness will be actually rated based on the reliability testing that we need to pass and what the electronic needs to withstand. On top of all of that, we are non-toxic. So all of the users of this coating are able to operate without any harsh environments or chemicals to being exposed to. Now, what is the PCBA coverage that we are talking about here today? So traditional conformal coatings, we would have a lot of keep outs, right? There's a lot of masking, a lot of, it could be either a user doing physically masking each one of those components that you see on the screen circled in yellow. And then we would apply the coating, then the PCBA would go into an oven for probably about 2 to 10 minutes, cure, and then progress into the manufacturing process. Now with our coating, we're able to coat the entirety of the PCBA without creating any type of keep outs. We dry between 10 to 30 seconds, as I mentioned before. We're friendly to the environment, and overall, we are between 20 to 30% lower cost. So our technology is actually proven. That's why we have backers such as TDK. But today we're super proud to say that we're in 80% of the EV vehicles, so electric vehicles here in North America, and we're expanding rapidly in Asia. So if you need to see any samples, want to talk about how to protect your electronics without any of the really harsh environment conditions, please let me know. More than happy to talk to you. Thank you.
Good afternoon, everyone. Thanks for having me, TDK, here to speak about Type 1 energy and our goal here to help mitigate some of the climate change that's going on, as well as help reach net zero by 2050. I think the energy demand that's overly increasing every year will require a real pivot and a real change, and so we want to commercialize fusion to support that change. So really, Type 1 Energy has 3 key areas for our strategy. First and foremost, it starts with the product. And here we're talking about Stellarator, which is a magnetic confinement fusion device. Really leveraging a number of enablers now that make today really a time to achieve this goal of commercializing fusion in the next 10 years, which really aligns well with the US DOE's decadal vision, which we're a participant in that milestone program, which allows us to leverage not only the DOE's resources, but also their expertise to do that and really go after that bold vision of the commercializing fusion in 10 years. The enablers really surround the fact that we've had some key demonstrations, that have proven the physics associated with stellarator confinement and stellarator performance, namely the HSX, which is from the University of Wisconsin. One of our co-founders was key there in both building that machine as well as analyzing the data off that machine and then proving the theory of the confinement, which we're going to leverage going forward. W7X, a machine in Germany, where we've now demonstrated extended periods of fusion, which provides us that science validation in order for us to proceed forward with our design of our own stellarator. Key enablers in materials, key enablers in high temperature superconducting magnets have now enabled us to leverage that higher magnetic field to build machines that are smaller and have higher performance. And then, of course, advanced manufacturing. So additive manufacturing, subtractive manufacturing have really leveraged and allowed us to use those technologies to build these complicated structures necessary for stellarators. And then the optimization for our plasma, they're really leveraging what's happened and done and demonstrated in W7X as well as HSX for us to use that theory for confinement of the plasmas. This wouldn't happen without the right people, and so Type 1 Energy has generated a team now that has that experience in stellarators. It also has experience in the science behind the technology. You can see there we've got a number of years of experience with the team, a number of papers and patents associated with these technology, and so certainly bringing those people together with the technology is our key strategy, and then that allows us to take this direct shot on goal, which really achieving that operation of a fusion pilot plant in the next 10 years, leveraging the people and really leveraging those enablers. So as we talk through what synergies might be available, now we've obviously had initial conversation with TDK, and we welcome those conversations and appreciate those conversations. But these certainly synergies would apply for a number of other people in this room as well. Obviously, this device like this requires specialized sensors, and so we're looking for any companies that have specialized sensors for temperature as well as magnetic field. High magnetic field sensors would be specifically of interest. Power supplies, in order to get to fusion burn, in order to get to where we have this unlimited energy, we need to first generate that power that's required to bring the fusion reaction. So additional help with power supplies would be specifically of interest. So we're talking about DC power supplies here for those HTS magnets. And then high voltage power supplies for the heating systems as well. So any of those areas would be of specific interest and potential areas for us to talk about synergies today. And then lastly, specialized filters. So as we operate these HTS magnets, we need to ensure that we can quench and detect the quench when needed in order to prevent any damage to the machine or damage to the equipment. So any specialized filters would be of interest. And then lastly, there's a lot of diagnostics that will need to happen. Some of that diagnostics obviously have been developed with the demonstration of these machines, but we're looking for any other specialized filters and other diagnostics that we can leverage for our machines going forward. All right, well, thank you TDK for hosting and appreciate the time.
I'm the general counsel of Grok. I haven't met Brian from Echo, but I feel your pain. They sent the lawyer, right? We're actually very proud to be one of the early investments of TDK Ventures. We were founded in 2006, and we focus on scaled compute hardware and software, specifically AI and ML. Raise your hand if you have used a large language model. Bard, ChatGPT, great. Silicon Valley kind of makes some sense. Have you also heard of a company called NVIDIA? NVIDIA makes graphic processors. Graphic processors were made over 30 years ago for gaming. The thing about graphic processors is I like to equate them to the learning process. It's training. You're training a model. It's like being in primary school, K through 12, right? K through 12, what do? You learn. And you know what? That's okay if you're slow while you're learning. I went to law school. That was a bad decision. I spent 3 years learning. That was training. Inference is here and now. Inference is asking a question and expecting an immediate answer. Let me demonstrate. I'm going to just pull up Suite. I'm going to pull up Bard. Tell me about TDK Ventures Investment in Machine Learning. I could take all of my time. You know why? Because this is running on a GPU or a CPU. Let me show you what Grok does. I'm going to ask the same thing running on Grok hardware and our compiler. See how fast that was? 10 times faster. That was almost 300 tokens per second. A token is a piece of a language, piece of a word. We're close to 400 now. My bandwidth is a little slow. What's really cool is I'm going to bulletize this. Cool. And then I'm going to ask it now in French. So that's the difference between Grok's language processing unit and a GPU or a CPU. People are now using CPUs because they're a little cheaper. But when it comes to actual inference, you need fast, you don't need slow, right? And what Grok offers users in the LLM market, right, is that immediacy that we're looking for. Faster is a user requirement. More affordable is a market requirement. Energy efficiency is a world requirement. With our language processing unit system, Grok is 10 times faster, more affordable, and more energy efficient. No other system out there can perform inference like we can with these results. So that is Grok, and we're running on 4-year-old silicon, and we're still 10 times faster, more affordable, and more energy efficient. So synergies with TDK, there's actually 30 of their components on our BOM, and they've actually provided some advice to us on going into the US government market. One of our greatest challenges actually is talent access. I would say 85% of the people that I work with are machine learning engineers, computer science engineers. I am not an engineer. I could barely get slideshow to work. And so that is our challenge right now in the market, is finding that talent to help us continue to program, to compile, and to build out our software. So thank you guys very much. I'm looking forward to speaking to you at lunch.
Hello, good morning, good afternoon. Thank you, TDK, for inviting us today. This is a fantastic setting. I want to think about how many of you are going to the beach, are going to next to water to find tranquility and to find peace. How many times we go to water for recreating our best memories. And at the same time, we don't realize that the very same water could be actually frankly, quite risky, quite dangerous, especially when it is in free form. And we're very good at understanding how much water we have when we have it in a container. However, now you don't know how much water is on the floor. So how much water is interacting with people, how much water is interacting and affecting our society is central to everything that we do. It's agriculture, it's manufacturing, it's producing textiles, it's drinking, it's living, it's enjoying, it's pleasure. But at the same time, it's affecting us all, and we see that on the news every single day. And not because I'm just looking at water on the social media and I have a lot of impact on that. I see that the water is affecting communities in Vermont, in New Jersey, Libya, India, Pakistan. No matter what you look at, Germany, a couple of years ago, no matter what you look at, water is an issue and it's putting people at risk. So what do you want to do is actually to look at how can we provide our customers a peace of mind that they can interact with water, and they can interact in a way that they can evolve over time and they can prove themselves that they can be sustainable. In a time of climate change, the key is adaptation, the key is evolution, the key is to understand how can I deal with this massive problem that is affecting so many people. So for that, DV Road is providing the missing water piece. And we're doing that with, frankly, a couple of very interesting corners. We're looking at combining the power of IoT and the power of data. If you just take one of these sites, you actually have no product. You have a sensor, but you don't have data. You don't know how to interpret that. And if you focus only on data, then you forget about the most important thing, how to look at the observable, which is the power of IoT. So DV Road is bringing together two massive, I'm going to use the word, mega trends. So IoT, artificial intelligence, big data, large-scale computing, all of it in a single solution. An end-to-end solution that enables our customers to understand how to live with water and how to provide business continuity, operational decisions, risk management, risk mitigation, et cetera, et cetera. So on the IoT side, what is special about DV Road? We have put together a very powerful and at the same time very slick sensor, which is capturing stray signals from satellites, which are bouncing on the ground. And at this very time, even we have signals inside this building that are bouncing on the ground and are producing an echo. And all we have to do is to listen. And we listen that, we put in together a patented, already certified, fully functional technology, which is providing us with a multitude of data types, from precipitation, snow accumulation, water levels, tidal changes, wave activity, you name it. Everything water or the lack of it. And on the other end, we have a very powerful data engine. So all the data that we're collecting from our sensors and also from publicly available sources, we need to curate them. We need to put it in such a way that it's actually usable. You want to have data of quality. You want to have models running on top of it to produce some potential outcomes. You need data that is actually of quality. So we're building the Google Maps of water, in a sense. Think about it this way. We have put together a massive amount of infrastructure, which is bringing us data from many locations in the world. I'm going to use a brag number, which is 17,000 locations today flowing into our data lake and being curated and being mastered. However, this brag number is also an opportunity. Seriously, 17,000 locations only collecting water in the world? This is pathetic. This is pathetic, and this is where we are here to challenge the status quo and bring this number to 100 times larger or 1 million times larger if we can. And this is where we do our work with the industry leaders. Not only we count with the backing of TDK, but we also count with other large organizations like Deutsche Telekom, helping us with communications, bringing the data into our cloud, and also a massive amount of data engine, which is coming from our other partner, Databricks. Thank you so much, and I'm looking forward to interacting with you.
Hey, folks. My name is Cam Dales. I think I'm probably the newest portfolio company here for TDK Ventures. In fact, other than a very small initial investment a few months ago, I think we got their first check last week. So Peak is a gigascale, or we hope to be a gigascale, sodium ion-based energy storage system company. So what that means, and we founded the company in June, is that we're attacking the problem of intermittency in renewable energy. And I think most people, when you ask them about the deployment of solar and wind, they understand the sun doesn't shine at night, the wind doesn't blow all the time, and of course we're going to solve that with big batteries on the grid. And most people think that that's actually happening. Turns out there's less than 5% of the total needed grid storage capability on the US grid, which is the most far along in the world, than is needed by 2030 to meet our global green energy needs. And so there's this massive pipeline of solar projects, wind projects that are extremely attractive economically as long as there's storage there. But the problem is that currently we're building big batteries out of lithium-ion battery cells. And I've been in the lithium-ion battery business for 15 years. It's a fantastic technology, particularly if you're doing things that are mobile. So your phone, your car, things like that. It's a perfect technology. Even the lowest cost lithium variant chemistry, LFP, iron oxide based technologies are fantastic for those markets that we're talking about in mobility, but they have some significant issues as you start to build them bigger and bigger and put them on the grid. Number one, way too expensive. Probably need to reduce the cost by 30-40% in order to be able to make these projects for grid storage pencil out. Number two, and those of us who have facilities in Moss Landing know they still catch fire. We've got a thermal runaway problem with lithium-ion batteries that's yet to be solved. So safety is a big issue as you put these cells together. As you think about putting them in the basement of Rockefeller Center, might not want to do that with a volatile chemistry like lithium. And then third, this has been the news significantly, is the supply chain challenges of critical minerals. Lithium itself, as well as the other high-priced metals that go into lithium-ion batteries. The continuing problem as we try to scale this out for grid storage applications. So Peak Energy, my co-founder and myself launched the company to go try to solve those problems. We're basing it on a technology called sodium-ion batteries. And I think, everybody, if you Google breakthrough battery, you'll see about 1 million different great R&D ideas out there of the next best chemistry. So why do we think sodium is going to be that next best chemistry? We're watching what's happening in the world, particularly in China, which is the global leader in battery production. They've announced over 150 gigawatt hours of capacity in the last 6 months. So sodium ion's happening. Peak Energy intends to be the first US-based company to build a gigafactory to build sodium ion batteries and then deploy them in world-class systems to support the grid and really enable the transition to green energy. So with that, thank you very much. It's great to be here, and thank you, TDK, for your support.
Good afternoon, everyone. My name is Anil Narasimha. I'm the CEO and co-founder of Mykonos. I'll first want to thank TDK Ventures for hosting a wonderful event like this, especially meeting some brilliant people here. So thank you for that. We're maybe a slightly different company. We're a deep tech platform company in the life sciences space. And so what we're actually really creating is a silicon chip architecture to deliver molecules into cells, biological cells outside of the body. And then the way we do that is by really kind of bringing 3 separate technologies together. The first technology is a MEMS chip that we've developed that has controllable silicon nanoneedles to directly inject any type of molecule, any type of cargo into a single cell. And I'll talk about the applications in just a second. The second technology is a microfluidics-based chip that we've developed that traps single cells into specific locations. And so you pair the needle chip with the cell trapping chip, and so you get one needle to one cell, but massively parallelized. The analogy I like to give is, I think most people are familiar with in vitro fertilization. It's super precise, right? It's one needle you're injecting into a cell. So take that, add silicon architecture to it and automation, shrink it down, and instead of one cell at a time, you're doing millions of cells at the same time. Right? And then the third component is a very critical component as well, is a surface chemistry that we've patented on the needle to facilitate attraction of a payload or a cargo or a molecule, and then release of that molecule once the needle is inside the cell, taking advantage of the cell's internal environment. And so you have your MEMS needle chip, your cell trapping chip, and the surface chemistry that kind of ties the room together. And that's kind of the crux of what we're building. So why are we building this? Our primary application focus is in personalized medicine. If people are familiar with cell and gene therapies, The cheapest cell therapy that is officially FDA approved right now is around $500,000 per treatment. But we're talking cures here. We're not necessarily talking just treatment, right? A lot of cell therapies, gene therapies are priced at $2 million, $3 million, right? So why so expensive? It's because the manufacturing of these therapies is a logistical nightmare, to say the least. And so our goal as a company is to really create an integrated platform from early discovery, so R&D, mean early drug development, early drug pipeline development, to manufacturing of these therapies. So kind of a one-stop shop for us to do that. And so we're fortunate to have TDK Ventures and TDK to kind of really help us out, especially on the engineering side, especially kind of things around chip packaging that we're doing, and the integration of the MEMS and the microfluidics chips that I was talking about. And so happy to answer any other questions, but looking forward to talking to folks at lunch. So thank you.
Hi, good afternoon, everyone. My name is Arch Rao. I'm the founder and CEO of SPAN. A little bit about myself. I've been in the energy industry for the last 2 decades, mostly working on solutions that help accelerate our shift towards decarbonizing our everyday lives. I spent most recently, before I founded SPAN in 2018, I spent a half a decade at Tesla helping design, develop, and deploy our batteries. So the home batteries like the Powerwall, but then scaling beyond that to commercial and grid-scale batteries, and subsequently ran global operations for Tesla for the energy business, where we deployed solar systems around the world, EV charging, and battery systems as well. It was interesting for me to see the deployment of tens of thousands of systems around the world, and increasingly find that there were some common challenges no matter where you went when you thought about scaling up decarbonization solutions. There are as you think about the continued adoption of solar or batteries or EVs, or as we look at alternates to fossil-based appliances in your home, where you think about replacing your HVAC systems, water heaters, and induction cooktops with electric alternatives, the home electrical panel becomes a fairly significant bottleneck to this decarbonization journey. And why is this important, right? If you step back and look at what are the 3 pillars for us to decarbonize, we're looking to electrify transportation, which has come in the form of electric vehicles. We're looking to decarbonize industrial processes, which is primarily looking at serving for electric hydrogen is a good example of a solution for industrial decarbonization. And then the third largest contributor to carbon emissions is our building stock. And we're looking at ways to not be dependent on natural gas to power our everyday lives. And I think that decarbonization journey is going to start for a lot of us with our home electrical panel. And that's the real opportunity. About 42% of emissions that we see in the US today comes from homes and the decisions we make in our everyday lives. So the cars we drive, how we heat our spaces, how we heat our water, how we cook our food, actually contributes to an enormous amount of the climate change impacts that we're seeing every day. And the challenge with making this transition is that existing technologies, while mature, are limited by the available electrical capacity in a home. So the solution that SPAN has been developing over the last 5 years is a smart electrical panel. So if you think about the circuit breaker box in your home, it's a fairly ubiquitous device, right? There is no home or building in the world that doesn't have an electrical breaker box. But that breaker box has been incredibly analog for the last century, nearly. It serves one purpose, which is electrical safety, but it can be a whole lot more given the unique place it has in a home. It's where the grid power lands, it's where new forms of energy like solar come in, and then it's where all of your appliances are fed into. The incumbent solution to allow homes to electrify is to replace this panel, is to upgrade power lines, is to upgrade transformers and power systems. And it's a very, very expensive and time-consuming solution because you're building an analog solution to a very technological problem today. Our product is designed to be a control system, or think of it as a digital power control system at the edge of grid. We replace home electrical panels when consumers are adopting solar systems or batteries or EV chargers, if you will. And by doing that, we're avoiding tens of billions of dollars of infrastructure investments going into the power grid in order to decarbonize homes. We've been around for the last 5 years. I founded the company in 2018. Over that period of time, we've had the fortune of bringing on board exceptional thought partners and investors like TDK, who joined us a few years ago. We've raised about $250 million to help us design, manufacture and now deploy these products across most of the United States. We're actually deployed in all 50 states. And our roadmap looks a lot like starting with an electrical panel in a home and expanding beyond that to enable homeowners to make that conscious shift from fossil-powered lifestyle to an electric lifestyle. So one of our first appliances is the home electric EV charger, which allows customers to get incredibly fast charging without the expensive cost of upgrading their service. We've now integrated with a number of heat pumps and HVAC solutions, and we're increasingly moving in the direction of being able to provide homeowners with home storage as well, which is a critical part of the solution when you think about a decarbonized grid. We see a lot of opportunities for us to work with TDK, and we're in conversations with TDK affiliate companies on how to bring these integrated solutions to market. But as we scale beyond this, hardware solutions that we're deploying right now, we really think of our product as being a software-enabled hardware. Ultimately, we're building gateways into every single home for all things energy and data. Once installed, we're typically in a home for 30 or 40 years with a gateway that is connected over cellular, over Wi-Fi, over Bluetooth, and is actually capturing an enormous amount of information about how you're consuming power, what appliances are approaching the end of life or potentially having issues that can be resolved. So increasingly where we're moving towards is a digital ecosystem of products, or a connected ecosystem of span homes, if you will, that can improve the quality of life by reducing your dependence on fossil fuels, potentially reduce the cost of appliance upgrades in your home, and at a grid scale or a network scale, be able to aggregate and dispatch resources to operate the grid more efficiently. Thank you so much for your time. Looking forward to speaking with you more at lunch. Cheers.
Hey everybody, thanks very much for having me today. We're also a very new member of the TDK team, so appreciate that. Thanks Henry, if he's out there somewhere. So let me quickly tell you about Nubis. So for Nubis, we make an optical module that's custom built and designed for machine learning AI networks. So many of you may know there's a big problem right now in machine learning, which is the size of the models, like for ChatGPT-3 and others, are growing at various metrics, 10,000 increase every 3 years, or 1,000 increase every 3 years, or 30x every year. There's lots of these metrics. And these model sizes ultimately make their way into the network because they get stored in memory, and then processors have to process those elements from the memory. And at the rate of growth of these model sizes to allow you to search on ChatGPT and like on Grok, are vastly outgrowing the size of the development of memory bandwidth in and out of GPUs, network speeds, whatnot. So the way that the industry is solving this problem is they're putting together larger and larger numbers of clusters of machine learning processors. So it used to be, say, 3, 4, 5 years ago, if you had a large cluster of GPUs from NVIDIA, it would be maybe 8 GPUs. And nowadays, it's very common to put 64 GPUs together or 128 GPUs together. Like the largest clusters in the world are up to maybe 1,000 GPUs right now. And what they're looking at over the next 2, 3, 4, 5 years is people are looking at clusters of 4,000, 16,000, 32,000, 64,000 of these machine learning processors clustered together. And when you cluster together this many processors, the math of a 64,000 node cluster is roughly 1 million optical connections in that single cluster. So to do that, you can't use existing optical technology. So in these clusters, just to give you a sense, are all going to be at individual rates of, I say, 100 gigabits per second or 200 gigabits per second. So in the perfect world, people would just use copper cables and connect them, but you can't get the distance traveled over a copper cable with these bandwidths. So everyone's looking at how do you solve this problem. It's not just an interconnect problem. There's many issues to solving this problem, but interconnect is a big one. And so in the interconnect space, you need to make optics that are orders of magnitude higher density, lower power, and more cost effective than the way optics are built today. So to do that, you have to take advantage of emerging trends in optics. So the big emerging trends in optics are whether you can leverage silicon photonics, which is a new technique for building optics, to build really high density optics, and whether you can use new sort of packaging techniques to build a piece of silicon, the silicon photonics plus other elements, super high density. So that's what we've done. We have a team of about 50 engineers, principally from a lot of Bell Labs heritage. We're based in New Jersey. We sampled our first product earlier this year. We're in the path of sampling to lead customers, and next year's a big year for us. We're going to have production silicon back, and we'll be in the process of taking this silicon to high volume manufacturing. In the optics business, transitioning to high volume manufacturing comes with quite a lot of risk. It's not like traditional CMOS silicon where you have to do lots of verification, but the actual manufacturing is done by TSMC and whatnot, and you're going to have a chip that works. So quite a bit of our challenge right now is this process of taking the chip to volume manufacturing. The chip itself is significantly higher density. It's 15 times denser than existing optical modules. It's at least half the power, so it has a lot of big attributes that are on the cutting edge and much better than existing solutions. But in this world, reliability is a big issue. Quality is a big issue. So even though people want to take technology risk, they want to take it only with certain assurances of quality along the way. So that's a big challenge for us next year. Our partnership with TDK is just getting started. TDK does have some advanced materials which can make silicon photonics much faster, which is an issue for when you move to 200 gig per channel. So that's something we're talking with the TDK team about. And I think that's a good quick summary. Thanks very much.
So at Vuria, we are developing a new manufacturing way to integrate optoelectronic devices at mass into the surface. So one application and the focus of the company right now is the micro LED displays, but we can use the same to do other devices as well. So why do we want to do this? If you look at the trend in the industry from autonomy to AI to a lot of self-driving, augmented environment, medical and personalized health, you need a lot of interaction, a lot of new HMI, a lot of sensors, and also a lot of display advances. And the challenge is you need a lot of functionality out of these HMIs. Very high resolution, multifunctional surfaces, high brightness, and new customization, and you need all those at very low power. And the challenge is most of display technology and manufacturing today cannot meet this requirement. So one of the solutions that people working around is micro LED. It can meet all this requirement on the paper, but the challenge is manufacturing it at the scale and at cost and affordability. And that's where kind of Vuria solution arrive. So hopefully the video play, yeah. So what we do, we take these devices that people made, the micro LED or micro sensors, and turn them to a cartridge, and we use the cartridge to directly print on the surface. So it simplified the process significantly. It improved it can be scaled to high volume and larger displays. The yield, because we do a lot of inspection, a lot of binning, we can get very high yield. And the performance of this is very high. If you traditionally, the way you manufacture these displays, you get very low uniformity. Because we can bin our cartridge in advance, we get very high uniformity. So some of the collaboration opportunities, it's a very complex field. We need to a lot of tools, materials, micro devices, and also application. And those are the field that we partners and collaborate a lot. On tool and material, we have some discussion and collaboration with TDK team. And on the devices, we work with a lot of partners to get different type of device, from a micro LED to sensors. And also on application, we work with OEMs, display manufacturer, and other companies. So we are kind of, if you look at the displays, in order to make a display, there are three kind of main component to it. The LED itself, these are the main players in the LED. They do a lot of improvement, either through enhancing the materials, integrating quantum dot, nanowire structures, or different type. The backplane where you define the pixels, there are quite a few players there. On the transfer side, based on all the feedbacks that we got from the industry, we are the most viable solution right now in the industry to meet a lot of applications. And that's the other good thing, is that we are compatible with any solution that this company develops, so we can mix and match different partners on the micro device, micro LED to the backplane side. Our roadmap, we started our company in 2016. The Round A funding kind of helped us to develop our tools, our technology. Round B, we are more focused on applications, a lot of automotive and wearable, and then the next stage for the companies to scale and move to the high volume production. And thank you for your time.